Hello there, and welcome to Smart Student TV, the only channel where academic and professional prowess is nurtured right from the comfort of your living room. Whether you are a student striving for excellence, a professional looking to sharpen your skills, or simply a lifelong learner, you are in the right place. In today's tutorial, we dive into a vital yet often overlooked topic: laboratory design and layout. A well-designed laboratory is the backbone of efficient scientific research and safe learning environments. The layout and design of a lab not only influence productivity but also play a crucial role in ensuring safety, functionality, and compliance with regulations. This chapter will focus on understanding the key principles of laboratory design, the factors to consider when planning a lab layout, and how a thoughtfully designed lab can enhance workflow while minimizing risks. Let's explore how to create laboratories that inspire innovation and ensure safety. Good laboratory design and layout is one of the most crucial steps in the establishment of any scientific laboratory. Safety and productivity are the two most important elements of a good laboratory design. If laboratory users are not safe, they will not be productive. A well-designed laboratory will help to create a hazard-free environment that will reduce risks of accidents and injuries, wastage of time and laboratory resources, besides also providing appropriate controlled conditions that will enhance the credibility of the tests and research findings. It is the objective of any laboratory to meet the needs that it was intended for, bearing in mind that the facility should be there to serve both in the present and in the future. Therefore, having a clear vision for the laboratory facility is a key element that will contribute towards the success of laboratory design and layout. However, having a decent laboratory design is not just a matter of common sense. It means creating optimal working conditions for your staff, increasing productivity, and, above all, increasing safety. Successful laboratories are the result of extensive planning, collaboration, and coordination between the design team and all impacted stakeholders. Even the smallest detail, performed incorrectly, can have a detrimental impact on lab function and safety. The design step, therefore, should not be done in a hurry but in a very sober and consultative environment where every input from all stakeholders, irrespective of the position or status, be considered based on facts and merit. Early involvement of stakeholders in the design process is critical. Failing to involve them early enough will certainly result in a cascade of future problems impacting design, construction, and long-term lab use. Stakeholders will help to identify internal opportunities for improvement, which if implemented can yield significant improvements in your lab. With the designer as the facilitator, stakeholders to be involved may include the owners, lab users, lab managers, faculty and staff, and facilities and maintenance personnel. Besides stakeholder involvement, it is also advisable to do benchmarking with other already established institutions having similar laboratory needs as the one you are envisaging to have. Benchmarking with such institutions will help to identify internal opportunities for improvement, which if implemented can yield significant improvements in your lab. Benchmarking may help laboratory designers to unravel more ideas about 1. Knowledge about what the facilities might look like. 2. Budgetary allocation. 3. Knowledge about the essentials required for health and safety. 4. Putting in place measures that could accommodate future modifications. Laboratories and lab environments are often considered to be among the most contaminated environment. This is because most experiments conducted within laboratories are potential health hazards to the surrounding. Experiments conducted may also be affected by the surrounding conditions, e.g. vibrations, noise, light, etc. It is therefore important to site laboratories appropriately, that is, 1. Away from cafeterias, health units, and other residential places. 2. Away from busy traffic, e.g. roads, railway lines, etc. 3. In proximity to delivery points, botanical gardens, greenhouse, and animal houses. 4. It should be oriented in east to west direction to avoid stray light from interfering with chemicals, which can explode due to exposure to sunlight. 5. Be sited as close to one another for easy management. Most of chemicals and substances used in the laboratories may be reactive to the materials used in the construction of laboratory walls and other surfaces, causing them to deteriorate faster. It is therefore very important to select construction materials that are either inert or less reactive to these chemicals. Laboratory facilities should be constructed of materials that 1. Are appropriate for the intended purpose. 2. Durable and comfortable to work on, e.g. not slippery. 3. that can offer maximum security and safety to the chemicals and equipments. 4. Minimize risks and hazards associated with the chemicals, e.g., prevent radiations from radioactive, oxidation, explosion, fire, and other forms of deterioration by the chemicals. Now let's look at a standard laboratory facility. What is a standard laboratory? And what basic features defines a standard laboratory? A standard lab facility is that which 1. Comply with health and safety regulations. 2. Is flexible in its ability to allow future modification. 3. Is spacious enough to accommodate the desired number of students without creating congestion. 4. Have a well-designed ventilations, lighting, and a good drainage system. 5. Is easily accessible and with good security. 6. Is designed using appropriate materials. What is a prep room and what features should it consist of? A prep room is a room designed to support practical work taking place in laboratories. Prep rooms are used for the preparation, maintenance, and repair of equipment and materials, and for the disposal of materials when they are finished with. Prep rooms should 1. Be located at a central place for easy access by the laboratory staff. 2. Be supplied with all main laboratory services, e.g. water, gas, electricity, and the fume chamber. 3. The entrance into a prep room should be restricted to those persons whose presence is absolutely necessary. 4. Have good supply of distilled water and at least one large sink and a dry working table with a cupboard, drawers, and shelves for storage of apparatus and reagents. 5. Have proper ventilation, lighting, and always be kept clean and orderly. 6. Have enough burettes, pipettes, volumetric flasks, etc. to enable bulk preparation of reagents. How about a laboratory store? Laboratory room is an important room within the lab specially designed for storing apparatus, chemical, and equipments. Laboratory stores should 1. Be situated in the ground floor with an emergency door opening on the outwards. 2. Be well ventilated and spacious enough to provide good clearance. 3. Have all the necessary safety measures put in place, e.g. fire extinguishers, shower rooms, protective clothing, and first aid facilities. 4. Be made of fireproof materials, and its shelves should be strong enough to be able to withstand the weight of chemicals stored on them. 5. Be made of fireproof materials, and its shelves should be strong enough to be able to withstand the weight of chemicals stored on them. 6. Discourage smoking and fire sources near the store. Laboratory floor surfaces. Just like the laboratory walls, laboratory floors are also consistently exposed to toxic chemicals and substances that may cause it to deteriorate. It is therefore important to select appropriate materials for construction. Various materials can be used for making the surfaces of the laboratory floors, e.g. wood, concrete, terrazzo, and linoleum, plastic, PVC tiles, etc. However, some factors should be satisfied for it to be considered appropriate for use. They should 1. Be resistant to chemical attack. 2. Be cheap and easy to clean. 3. Not be noisy. 4. Offer maximum safety and comfort. 5. Be beautiful to the laboratory user. Laboratory lighting and ventilation. Laboratories must be constructed in an environment that is exposed to good lighting and ventilation. Ventilation means free circulation of air in and out of the laboratory. Good ventilation is important in the laboratory. This is in order to rid the laboratory from dangerous fumes. There are two types of ventilation. A. Natural ventilation. Include all ventilation that allows in fresh air, e.g. through windows, doors, etc. B. Artificial or mechanical ventilation. Is achieved by means of fans, air conditioners, fume chambers, etc. Lighting in the laboratory is very important to enable the occupants to easily see and work comfortably without straining. Lighting also provides an agreeable working environment and warmth. There are two types of lighting in the laboratory. These are A. Natural light includes daylight, passing through the laboratory windows and doors. B. Artificial lighting includes use of electric bulbs and fluorescent tubes. Good lighting can also be achieved through painting of laboratory walls with bright or light reflecting paint. Laboratory services. Laboratory services are considered the most essential components of the lab. Without them, most activities will stall. There are 4 basic laboratory services, They include 1. Water. 2. Electricity. 3. Gas. 4. Fume chamber. 5. Internet services. Laboratory fixtures and fitments. Laboratory fittings refer to the various fixtures, equipment, and accessories that are essential for setting up a functional laboratory. They include 1. Benches. 2. Water taps. 3. Gas taps. 4. Sinks. 5. Electric gadgets. 6. Fume chambers. 7. Fire extinguishers. 8. Shelves. 1. Laboratory benches. Laboratory benches provide surfaces upon which laboratory experiments and tests are done. There are two main patterns of laboratory benches. A. Permanent assembly benches. B. Unit assembly benches. Permanent assembly benches are permanently fixed, hence do not allow future modification, or else they must be destroyed in case necessary changes are to be made. They are designed for specific purposes. These are benches on which laboratory services, e.g. water, electricity, and gas taps should not be placed on them. Unit assembly benches are temporarily fixed, flexible, and movable, and therefore can allow future modification. Laboratory benches can also be classified into the following three categories based on the positioning in the lab. A. Wall benches. They run along the side walls of the laboratory. Heavy equipments, water, taps, and gas taps are usually placed on these benches. B. Island benches. They occupy the center space of the laboratory. In majority of labs, they do not have water, gas, and electricity taps. C. Demonstration or lecture benches. These benches are usually found at the front of the lab near the board and are used by the teacher or technician when demonstrating an experiment to students. Benches should have enough working surface area and good working height. For student benches, it is recommended that they have a working surface area of approximately 0.36 meters square per pupil. The height should be 900 millimeters with good clearance for legs when the pupil is seated at the bench. A measurement of 240 to 270 millimeters from the top of the stool to the underside of the worktop allows sufficient upper leg clearance for one to sit comfortably at the work surface. All laboratory services, e.g. water, electricity, and gas taps should be installed only on the wall and demonstration benches, not on island benches. Be within the reach of persons sitting next to the bench, i.e. within 600 millimeters radius, and be of the same height as the pupil benches. The perimeter benches should be on two walls and with adequate structures to support it. The materials for constructing laboratory benches should be 1. Suitable for the intended purpose of the laboratory, e.g. for medical, biological, or chemistry lab. 2. Cheap, durable, easily available, and easy to clean. 3. Poor conductor of electricity. 4. High mechanical strength and free from vibrations. 5. Resistant to chemical and water attack. 6. Free from shrinkage and distortion. 7. Do not burn easily. Some of the most common materials used for making laboratory benches and benchtops include A. Wood. B. Metal, e.g. stainless steel or aluminium. C. Concrete. D. Plastics, etc. Each of these materials has got its own advantages, disadvantages, and the types of laboratories most suited to be used for construction. 3. Stools. Stools should also be designed to allow enough leg space and appropriate height for people to sit at the bench. 4. Doors and windows. Doors and windows not only provide for entry and exit of the lab, but also assist in ventilation and lighting. They must therefore be wide enough to provide for natural light and ventilation, be easily accessible, and should have restricted openings, which can nevertheless be opened fully in the event of an emergency. 5. Laboratory drainage system. Laboratory drainage system plays an important role in the supply of water and disposal of laboratory effluents. It consists of taps, sinks, and traps. The layout of the drainage system is an important aspect that must be thoroughly considered during laboratory design. The water supply tanks should be positioned high enough to provide pressure to operate science equipment. Taps. The position of taps and sinks is very important and should be done in accordance to the type of work to be done on a bench. Taps should be placed at the center of the bench or on the sides to allow for communal work. They should not be placed next to electric sockets for safety reasons. Water taps should be at least 300 millimeters above benches, and with the sprout at least 225 millimeters above the sink. Sinks should also be provided for washing and rinsing various laboratory wares. One water tap and a sink is recommended per 6 pupils spaced around the lab, and each should be large enough for experimental equipment. Another sink and water tap should be included in the fume cupboard. Sinks can be made of plastic, stainless steel, ceramics, etc. There are 2 types of sinks. A. Rimless sinks. B. Rimmed sinks. Rimless sinks. These sinks do not have rims and are fitted tightly on the bench. Rimmed sinks. They have rims that lie over the bench surface. There are 2 types of rimmed sinks, externally rimmed sink and internally rimmed sink. The fittings of the sinks should be such that they should not allow leakage or flooding of the water. Rimless and internally rimmed sinks are recommended for use in laboratories because they are easier to wipe out dirt from the bench into the sink. The space between the back of the sink and the bench should always be made watertight to prevent seepage. Next, let's look at the water traps. A water trap is a device or fitting under the sink that traps water. Trap serves many functions. These include: 1. They receive waste from the sink and disposes it into the main drainage system. 2. They act as a dilution tank for corrosive liquids before being discharged so as to protect the piping. 3. They also trap insoluble solids flowing down from the sink so as to prevent the piping from being blocked. 4. They prevents foul smell from getting back into the laboratory by cutting off the drain interior atmosphere from the exterior air by preventing foul gases in the drain from escaping. The effectiveness of a trap is dependent on the depth of the seal, since the deeper it is, the more it will resist the pressure inside the drain. All traps must be able to meet the following requirements to be effective. 1. Simple in design. 2. Accessible in all parts. 3. Made of hard, smooth, impermeable material. 4. Self-cleaning in action. 5. Be smoothly rounded with no sharp angles or corners. 6. Holding minimum amount of water but with effective seal. 7. Must not retard the flow of water. The most common materials for laboratory water traps are plastic, PVC. 6. Laboratory gas supply system. Gas systems are used for distribution of fuel gas in science laboratories. For efficient distribution of gas in the laboratory, 2-way outlet gas taps with safety locks are recommended. They should not be opened by accidental knocks. Furthermore, all gas taps not to be used should be properly secured in order to avoid pupils' accidental opening. However, the master gas switch should be positioned at a readily accessible location and the on-off position be clearly indicated. Gas tap should be fitted on the wall benches, demonstration bench, and fume chamber. They should be of robust design, with definite on-off positions and anti-rotate fixing to bench, with non-return valves and restrictors in nozzles. Gas taps must be spaced around the lab with 1 tap per student is recommended. The rubber tubing connecting the gas taps to the Bunsen burner should be of the type suitable for use with the gas being supplied. Both end tubing should be held in position by horse clips to prevent loosening. 7. Electric switches. 1 electrical socket per pupil is recommended. As with gas taps, other sockets should be provided on demonstrations benches and in the fume cupboard. Electrical sockets should be of robust design and must be away from water taps. 9. Pipes and cables. All pipes and cables should be installed in or behind bench walls or floors. None should be hanging from a ceiling, except for bulbs and other ceiling-mounted data projectors. Pipes and cables should be color-coded according to contents and show the direction of flow. Gas, electricity, and water supply should all have their master control points that are easily accessible by the lab technician or teacher but not the student. 10. Fume chamber. Fume chamber is designed to prevent contamination by drawing out poisonous or dangerous fumes from the laboratory. They should be designed in such a way that will only allow fumes to be drawn out of the laboratory and not inside. Fume chambers consist of transparent panels made of sliding glass that provides a working space for operation. The services to be installed inside the fume chamber include: A. An electric switch and pilot light. B. A water tap. C. Sink. D. 2-way gas tap. E. Motor. Based on the type and position of these motors, fume chambers can be classified into two. I. Direct system. The second, indirect system. I. Direct system. The motor is placed directly above the fan in line with the fumes from the lab. The motor is small and cheap, but wears out easily due to direct exposure to fumes, hence needs constant replacement. The second, indirect system. The motor is placed separately from the fan and is not in line with the direction of movement of fumes from the laboratory. The motor is big and do not wear out easily. It is, however, expensive. How to use a fume chamber. Before using a fume chamber, it is important to ensure it is in good working condition. 1. Switch on the fan and adjust the vertical sliding glass to give a reasonable working space. 2. Place your reagents and substances accordingly and ensure that the reaction shall take place as required. 3. Close tightly, ensuring that no fumes escape out of the fume chamber. All fuming chemicals must be opened inside a fume chamber. 11. Biosafety cabinet. A biosafety cabinet, also known as a biological safety cabinet or microbiological safety cabinet, is a ventilated laboratory workspace that allows users to safely work with materials that are contaminated with pathogens. Biosafety cabinets work by creating an airflow barrier that protects the user and samples from biohazards. 12. The shelves. Shelves should be ergonomic and approximately 2 meters high, stable and secured to a wall. Stepladders should be provided, height equal to the top shelf, with grab rails and platform. 13. Fire extinguishers. Fire extinguishers are equipments used for firefighting. There are many types of fire extinguishers. These include 1. Water fire extinguisher. 2. CO2 fire extinguisher. 3. Dry powder fire extinguishers. 4. Vaporizing liquid. 5. Foam. 6. Fire blanket. 14. Emergency showers. Emergency showers are very important because they are used to extinguish fires when somebody is on fire or to wash away chemical from the body surface if spilled upon. Emergency showers must be placed in an easily accessible position. They should be connected with a water storage tank. They must be regularly tested and properly maintained.